Okay, hi class. This is a 1.2 exponential function, and as you see the same graph we practiced in 1.1. So I want you to do one more time so that you can upload it for me and you get to review one more time. Practice makes it better, and let's play with me. So we are going to start the appetizer part of the exponential function. And let's try to think about what is the exponential model in our life. As you see that we are going through coronavirus lately, and that is you guys have seen flatten the curve, and that is actually exponential function. If you are in my pre-cal, we actually talked about this one and then also finding the equation. So coronavirus is one of the most useful example for now. Another thing you can think about is all the memory of a cell phone and computers. It used to be like 4 megabytes and then 8 megabytes, 16 megabytes, and now you see the gigabytes. So if you think about also the memory of the computers or cell phone, you can think as exponential models. And you guys are actually living in exponential world, so don't forget that you have to keep up with exponential world right now. So I want you to see in appetizer part the distinguishing between linear function and exponential function. Linear function we actually talked about before, that the number pattern will be the addition and the exponential function will be multiplication. So function has a form as mx plus b. In this case, m is a slope and then b is y-intercept as initial point. Exponential function has a format of y is equal to ab to the x. In this case, a is the y-intercept as initial point and this b is a growth factor. That means how much it multiplies. So if you look at these two examples, it probably looks so familiar because we already done it before. So let's talk about population P and Q. And this is since 1950, the population of one of the area. So P, when you observe the patterns, each time your number is going to be added into 50 over 10 years. And if you look at population Q, each 10 years the number is going to be multiplied by 2. So I can say that linear model will be P, exponential model will be Q. Then let's try to find the equation for model P. So this is going to be y is equal to increasing 50 every 10 years, starting with number 200. So I can say 5x plus 200 as this linear model. If you look at Q, this is going to be y is equal to starting number 200 and multiplies by 2 over 10 years. Without this 10, you can just say that every year multiplies by 2, so it doubles. But if you by putting 10, every 10th year is going to be doubled, which is a 10 over 10. So in this case, the equation will be exponential function 200 times 2 to the x over 10th power. Now, here's the in-class activities. Please pause the video and then try by yourself for a couple of minutes and compare the answer with me. Good luck. Okay, if you get to finish the in-class activities, please compare your answers with mine. And if you got the correct answer, excellent job. If not, you can always ask me, or you can always compare the answer and then look at my work. Okay, so let's look at example 2 of an appetizer. It's the same format as the previous one. Just so let's double check if you can do this one. When I look at the A, I want to see that this one is subtracted by 10 each time. So this will represent the linear equation. So I can rewrite as the equation y is equal to negative 10x and starting number 40. Okay, so we are waiting for in-class activities 2B and C. So I'll wait for you and try to do it in-class activities B and C for next few seconds. Okay, so I want to check the answer for the in-class activities. The answer for first one is 90 times 1 over 3x. The second one is 4 to the 3 to the x. What you need to be careful here is, although it is divide by 3 exponential function, we always express with multiplication. So instead of using divide by 3, you can rewrite as times by 1/3. That we will use as a growth factor. Okay, class, let's start the main dish. So by reviewing some of the pre-cal, I want to refresh some of the main idea of the exponential function. So look at the example first, if you get the idea which represent the growth factor and which represent the y-intercept as initial value. So the population P of the ants in your kitchen starts at 10, increased by 5% per day. So I see that starting number 10 increased by 5%. I can write it as y is equal to AB to the x format. And starting number 10 increased by 5% will be 1.05, because you have 100% top on there, you're gonna add 5% more. Because if it's less than 1, that means it's decreasing, but it's increasing that your growth factor has to be greater than 1. And then don't forget your power x. Okay, so let's look at next one. The value of a V of a 1982 Chevy Caprice starts at $10,000 and it decreased by 8% per year. So we are going to use the same format as AB to the x. As you guessed, our starting number is going to be 10,000, and then careful, my growth factor will be 0.92 to the x. Why do I get 0.92? Because I'm keeping 92% and giving 8% away. So still, you see that the number is less than 1. This is a decreasing exponential function. So I'm giving away 8% and then I'm going to keep 92%. Now, here's the in-class activities. I want you to think about third question quickly. I want to pause it and then see if you can get the right answer. So let's check the answer of ICA in-class activities 3. The air pressure starts at something millibars and the sea level is 0, decreased by something per mile increase in elevation. So if you look at here, I see that my starting number is going to be 960. So it starts at 960 at sea level, and then it's going to be decreased by 20% per mile. Because as you can see, it's going to be 0.8, so that will be decreased by 20%. Now everybody, let's look at the main dish of page number 3 of 1.2. I'm going to explain example number 4. So let's look at the question. Says total 40,000 salary of a new job and between 6% increase per year versus 3,000 per year increase since year 2010. So let's try to see that if we increase by 6% versus 3,000 per year. One of them will represent the exponential function, one of them will represent the linear function. So which one do you think is going to be exponential function? As you see, the percent will represent as 1.06 as your growth factor. It will be your exponential function. So let's set up the equation for A and B. It's increasing 3,000 per year. Easier way to distinguish the slope is they're gonna have always 2 units. In this case, I see that 3,000 per year, and then starting number is $40,000. So my linear equation will be $3,000 per year plus starting number $40,000. As we discussed, B will be exponential function and starting number, as you guessed, 40,000, and then our growth factor will be 6%. Top 100% I'm making, so it's gonna be added a 6% each year. So I can put it 1.06 to the x. Then I wanna see that if you're an employee of 2020, which one will be better deal for you? Should we stay with this one or should we stay with the other one? So that means 10 years later, I can calculate of f of 10 for A. And as you see, 3,000 times 10 is going to be $30,000 plus 40,000. That will make 70,000 as your income for 10 years later. How about B? 10 years later, what am I gonna get? Let me punch into the calculator quickly. So 40,000 times 1.06 to the 10th power. When I punch in, I get actually little bit more than $70,000. So if you are going to work for 10 years, probably 6% raising will be increased faster. But also you can actually think about this way. If you are working less than 10 years, you can actually go for this format because you will actually get paid better. It's gonna increase this way versus increasing that way. Then why you wanna choose that one? Because you get paid. B pays better. Okay, so now we are waiting for in-class activities number 4. I want you to read the question and then pause the video and try to see if you can get the answers. Good luck. I want you to check the answer for your in-class activities. When I have A and B, these are the equations that I have. And then after I plugged in the value of the 10th year, which represented 2020 of year, and that will show that actually linear function is going to be higher, so you want to use the exponential function. So which one is a better deal for you in this case? You want to increase 3% per year because it's lower than increase by $500 per year. So you want to use the B case because tuition is going to be cheaper. Okay, so it's going to be last page of 1.2, our dessert question. It's a little bit challenge, and each section is going to get harder and harder. So I want you to keep participate and then go over together with me. So example 5 with dessert. If you're having hard time, this is the same question as example 1 of your textbook. It shows all those solutions one by one. So if you're having hard time, just go over with the textbook one more time. So here says the function is the exponential function, and they gave me those 2 coordinates. I want to find the base, growth rate, and then evaluating given function. So let's look at here. If I know the exponential function has a, b to the x as my form. So by plugging those numbers, I will have 88.2 is equal to a b to the 20th power, and the next one is 91.4 is equal to a b to the 23rd power. So if you look at this one, is going to be system of equations, 2 equations and 2 variables, so we should be able to solve this one. So how are we gonna solve this? We are using the ratio. Then second equation is given this way. So by dividing these 2 equations, as you see, a will get cancelled out. So b to the 3rd power is 91.4 over 88.2. So by punching to the calculator, b value will be I got 1.01195. So my base will be 1.01195. Then be careful, I want to find the growth factor. The growth rate will be 0.01195 because the top 100% is increasing about 1.195%. So this is going to be your growth rate. Then in order to evaluate the function of input 25, we need to find the original equations. So I have my b value given as 1.01195, and then I have one of the equation out of 2, 88.2 is a b to the 20. By plugging in here, I can find the a value. In order to find a value, you can divide by the factor of right hand side. And from here, if I punch into calculator carefully, I get 69.5484, something like that. So I can rewrite my equation is y is equal to 69.5484 times 1.01195 to the x. So if you plug in 25 in here, f over 25 in here, then times 1.01195 to the 25, I get 93.5974 as an answer. So my C value evaluating the 25, I get this value. Okay. I want you to try in class activities number 5 and compare the answer after you finish it. Good luck doing your in-class activities. Okay class, let's check your in-class activities answers. If you look at the A, find the base. I got the base of a B value 1.499978. And if you want to find the growth rate, that is going to be in percent. So without the 1, it will represent 49.9978%. You could round it up to 50%, but as you see, I probably don't like to in this case, so keep it this way. Those who want to find the equation all the way through, then if you can plug in the b value, find the a value in here, and then your equation will be shown as highlighted part. Let's continue with in class activity 6. Also, this is going to be your textbook question number 25, and I saw at one of your homework questions. So when you look at the function of a g, h, and k, as you see that all of these functions are increasing, but they're increasing different way. First one is going to be increased by 1 and 2 and 3. H function is increased by 10, 9, and 8. K function is constant increase of 0.3 each time. So as you see, all these three cases are increasing, but depending on the rate of change, you can see that which one will represent which function. So first one is going to be constant, that is going to be 0.3. So k represents function a. And if you look at the g function and h function, g function first it increased by 1, and then after they increase by 2. So each time it's going to be increased fast. So g function represent graph C, and then b function, first your slope was 10, and then it's slowing down as 8 in here. So your function will be b. So these are the main concept for the calculus class, because depending on, although all are increasing, this will increase linearly, logarithmically, and exponentially. And that's what we are going to distinguish in calculus class. So I want you to figure it out. Although it's all increasing, they are increasing different way. G will be C, and the H function B, and then K function will be A. I want to actually mention about the last part here. I want to give you a little bit of help to how you can perform the homework. So your homework is going to be always on Monday, 6 a.m. So this homework 1.2, also I want you to turn it in by 6 a.m. of Monday. And then if you're having hard time doing those homework, I also indicated those questions relatively very similar to the question you will see. So if you look at those questions on your textbook, and there is also solution on the canvas, you can compare that before you do the homework so that you can get the correct answer. And I want you to actually print it out all over those papers. Each paper, each section I try to make it 4 pages, and print out all 4 pages, and then follow with my video instructions and go over all those questions with appetizer, main, and dessert with the in-class activities. After you finish it, I want to take a photo with your cell phone using Adobe Scan, and then you can upload it onto Canvas assignment 1.2. If you have any questions, you can always email me, or you can meet me through the Zoom office hour. And good luck doing your homework.